Hey, this is Mr. Warden. I'm going to do a video key on the Do Now for week 17, day 2 for algebra. So first of all, we got the basic question. What is the slope of a line that goes to the points -9, 28, and 51, 2? So to work this out, we need to use the slope equation. We take our 2 points and we find the difference in the y values. It doesn't matter which way we start. We just pick a direction to start with. Let's start with 28 minus -2. Those are the y values. So 28 minus -2. That's my numerator because that's the change in the output, the change in the y. Then I'm going to figure out the change in the x's, and since my subtraction starts with 28, I need to start with -9 for the change in x. So -9 minus 51. And it's really important that I keep this point here, the -9, 28, and this point here, 51, -2, together and, and keep it going in order. So this is going to end up equaling, this equals 30. So that's 30 up here. And this equals -60. -9 minus 51 is -60. Now, of course, 30 over 60 would be 1/2. So 30 over -60 is -1/2. Okay, so the slope here is simply -1/2. That's what it boils down to. I could have gone the other way. -2 minus 28 would have given me -30, and 51 minus -9 would have given me 60. So it would have been -30 over 60, which is the same thing. Okay, let's take a look here. In the last question, hopefully you got this slope of -1/2. Oh, look, I'm giving you some resources to check to see if you got it right, and that's right. So because the slope equation does lead to -1/2. So a slope-intercept form equation would be written as y equals mx plus b, and since our slope is -1/2, we can say, so it's the basic structure is y equals slope times x plus the y-intercept, or b is what we usually call it. But since the slope is -1/2, we replace m with that, and then we just have to figure out what b is. Well, there's a couple of ways to approach that. One way to approach that is to simply look here and we know an x and y value. In fact, we know two x and y values. We can replace x with this 28 and y with that -9, or we can replace x with this -2 and x with, what did I just say? Let me back that up. We can replace x with -9. I just did a Jimbo mistake. With -9 and y with 28, or we can replace x with 51 and y with -2. And once we do that, we'll just have b to solve for. So that's one way you can approach it. So let's try that. I'll pick 28 for y. So 28 is going to be y, and then it's -1/2 times -9 plus b. And now we just have one variable to solve for, and that's super easy. You just need to isolate that variable. So we end up with 28 equals, let's simplify -1/2 times -9. Well, half of 9 would be, of course, 4.5. And since it's a negative times a negative, the sign remains positive, so it's just 4.5 plus b. And now we can figure out what b is by subtracting 4.5 from both sides. So we say minus 4.5, and then minus 4.5, and then we end up with 23.5. So 28 minus 4.5 is 23.5. Oops. Okay, and 4.5 minus 4.5 is nothing, so all I'm left with over here is b. So the thing that I would need to add is 23.5. So when I write my equation, it needs to be y equals negative 1/2 times x plus 23.5. And 23.5 is going to be the y-intercept. Okay, so the y-intercept is b will equal 23.5 at, and that's the y-intercept, which will be at the point 0, 23.5. And there you have that. All right, now let's go on and take a look. So I laid out a sort of summary of that here, so you can, of course, check your work as you go in the Do Now. And now let's consider these 2 points that we just worked with. And Jimbo has decided to set up a point-slope form equation with them. So I'm going to open up a Desmos to illustrate what went wrong in just a second. But here's what he did. He came up with the following equation. He said 28 minus negative 2, because he sees this point-slope form structure. He says y minus y1 equals slope times x minus x1. And he goes 28 minus, he says, okay, one of the y values is 28. The other y value is negative 2. And so he says 28 minus negative 2 equals negative 1/2 times, that's the slope right there, times negative 9, that's the x value, minus 51. It seems like he's got everything in order, everything's going in the right way, but when he tries to graph it, nothing happens. So let's actually open up a Desmos and test this all out. So, oops, that's not what I meant to do. Desmos. And here are the points. I'm going to clean that up. So that should plot those points. I will label it. I'm going to zoom out so you can see the points. There they are, here and here. And so what he did was, let's go here. He did this equation, 28 minus negative 2 equals negative 1/2 times negative 9 minus 51. Okay, and what did he do wrong? No line shows up going on between these. It seems he's got everything in place. Well, here's what's missing. What's missing is this is just a true statement. This just says 30 equals negative 1/2 of negative 60. And if I boil all this down, that's 30 equals negative 1/2 times negative 60, which is just true. That's just a true mathematical statement, and that's great. But it doesn't make a line equation, because a line is an infinite set of xy values, xy points that taken in combination make an equation true. And so what we really need is, and if you go back to this, what we really need is actually an x and y variable. So this y and this x are not actually the numbers that are in the points. It's just this and this. So this y and this x need to be variables, because we're trying to generalize the relationship. So if I replace 28 with y, so let me leave that 28 there for a second. I'm going to actually copy pasta this. If I replace 28 with y, and I replace negative 9 with x, now I've generalized for any xy point that is on this line. It's not just any xy point, but any xy point that is on this line will have this relationship, because this will be a change of y. This is a general change of x and a general change of y. And this general change of y over this general change of x is always going to be negative 1/2 for this line. Now, some of you might have wondered, why is x and y there? Why not the other way around? Could I have done it this way instead? Could I have said x here? Let me actually turn that one off. And maybe I could have said y here instead of putting the y there. And if you were thinking that that would work, you're right. Because this is just another generalized change of y and another generalized change of x. All right, I hope this has helped clarify. This is certainly true, but really, if you want a line, you need the x and the y. Because this is actually a statement that describes a relationship between x and y values anywhere along this function, everywhere on this function. All right, I hope that helped, and I'm going to stop now.